Fire alarm wiring within an elevator hoistway does not necessarily need to be installed in a raceway. The National Electrical Code, or NEC, provides specific guidelines for wiring methods in various locations, including elevator hoistways. While the NEC mandates certain wiring methods for general applications to ensure safety and prevent electrical hazards, there are specific allowances and exceptions that apply to fire alarm systems. It's important to differentiate between general power and lighting circuits and the dedicated circuits for fire alarm systems. Fire alarm circuits are designed for survivability and reliability. Therefore, the NEC contains provisions that allow for alternative wiring methods that enhance their performance during a fire. The NEC Article 760 covers fire alarm systems. It outlines the requirements for the installation of fire alarm circuits, including the types of wiring methods permitted, conductor sizes, and overcurrent protection. Section 760.41, for example, addresses wiring methods and materials on the load side of the fire alarm control unit. This section refers to other articles within the NEC that provide further detail on acceptable wiring methods. When considering the specific environment of an elevator hoistway, it's crucial to take into account the potential mechanical damage that wiring might be subject to. Elevator hoistways contain moving equipment, such as elevator cars, counterweights, and related machinery. The NEC requires that wiring be protected from physical damage to prevent insulation breakdown, short circuits, and other hazards. This protection is generally achieved through the use of raceways like rigid metal conduit, electrical metallic tubing, or flexible metal conduit. However, the NEC also permits the use of cable types specifically listed for the purpose, such as metal-clad cable or mineral-insulated cable, which offer inherent physical protection without the need for a raceway. The decision to use a raceway or an alternative wiring method depends on several factors, including local codes, the type of cable used, and the level of physical protection required. It is essential to consult the authority having jurisdiction or ARJ to determine the specific requirements for the installation. The AHJ is the local governing body responsible for enforcing the electrical code, and they may have additional requirements or interpretations that supplement the NEC. Another consideration is the type of fire alarm system being installed. There are two main types of fire alarm systems: non-power limited fire alarm circuits, or NPLFA, and power limited fire alarm circuits, or PLFA. NPLFA circuits operate at higher voltages and currents and generally require more robust wiring methods, often including raceways. PLFA circuits, on the other hand, operate at lower voltages and currents and may be permitted to use more flexible wiring methods. The NEC specifies different requirements for NPLFA and PLFA circuits in Article 760. For NPLFA circuits, Section 760.49 details the wiring methods. These methods include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, rigid non-metallic conduit, and other suitable raceways. In some cases, cable types such as metal-clad cable, RMC, or mineral-insulated cable, or MI, are permitted without a raceway, provided they are adequately supported and protected from physical damage. For PLFA circuits, Section 760.52 allows for a wider range of wiring methods. These methods include the same raceways permitted for NPLFA circuits, as well as other cable types such as fire alarm cable, or FPL, and communications cable, or CM. The specific cable type must be listed for the purpose and installed in accordance with its listing. It's important to note that even when a raceway is not explicitly required by the NEC, it may still be a good practice to use one. Raceways offer several advantages, including physical protection for the wiring, ease of maintenance and future modifications, and a neat and professional appearance. Additionally, some local codes may require raceways for all wiring in elevator hoistways regardless of the NEC requirements. When installing fire alarm wiring in an elevator hoistway, it's essential to follow these best practices. Firstly, carefully review the NEC and any applicable local codes to determine the specific requirements for wiring methods in elevator hoistways. Secondly, select a wiring method that provides adequate physical protection for the wiring, taking into account the potential for mechanical damage. Thirdly, ensure that all wiring and equipment are properly supported and secured to prevent movement or strain. Fourthly, use only listed and approved materials that are suitable for the intended application. Fifthly, follow the manufacturer's instructions for the installation of all wiring and equipment. Sixthly, obtain approval from the authority having jurisdiction before energizing the fire alarm system. In summary, while the NEC does not always mandate the use of a raceway for fire alarm wiring in an elevator hoistway, it's crucial to carefully consider the potential for physical damage, the type of fire alarm system being installed, and any applicable local codes. Consulting with a qualified electrical contractor and the AHA is essential to ensure that the installation meets all applicable requirements and provides a safe and reliable fire alarm system. Furthermore, it is imperative to adhere to NEC Article 725 regarding Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits, if applicable to the fire alarm system. These classifications dictate specific wiring and installation requirements based on voltage and power limitations. The chosen wiring method must align with the circuit classification to ensure safety and compliance. Consider the ambient temperature within the elevator hoistway. Elevator machine rooms and hoistways can experience elevated temperatures, especially during warmer months. Select wiring and raceway materials that are rated for the expected temperature range. The NEC provides guidance on temperature ratings for conductors and insulation. Using materials with appropriate temperature ratings ensures the wiring system's long-term reliability. Moreover, proper grounding and bonding are critical for all electrical systems, including fire alarm systems in elevator hoistways. Grounding and bonding minimize the risk of electrical shock and ensure proper operation of the fire alarm system. Adhere to NEC Article 250, which covers grounding and bonding requirements. Pay close attention to the grounding of metal raceways and equipment enclosures. The grounding conductor should be properly sized and connected to the building's grounding electrode system. Also, consider the potential for electromagnetic interference, or EMI, in the elevator hoistway. EMI can disrupt the operation of sensitive electronic equipment, including fire alarm systems. Shielded cables and proper grounding techniques can help minimize EMI. If EMI is a concern, consult with a qualified electrical engineer to develop a mitigation strategy. When running fire alarm wiring alongside other electrical conductors in the elevator hoistway, maintain proper separation to prevent inductive coupling and other forms of interference. The NEC specifies minimum separation distances for different types of conductors. Maintaining adequate separation helps ensure the integrity of the fire alarm signals. In addition to the NEC, other standards and codes may apply to fire alarm systems in elevator hoistways, such as the National Fire Protection Association or NFPA 72, which is the National Fire Alarm and Signaling Code. NFPA 72 provides comprehensive requirements for the design, installation, and maintenance of fire alarm systems. It's essential to be familiar with NFPA 72 and any other applicable standards to ensure that the fire alarm system meets all necessary requirements. Regular inspections and testing of the fire alarm system are crucial for maintaining its reliability. The NEC and NFPA 72 provide guidelines for inspection and testing procedures. Schedule regular inspections and tests to identify and address any potential problems before they can compromise the system's performance. Keep detailed records of all inspections, tests, and maintenance activities. These records can be valuable for troubleshooting and demonstrating compliance with applicable codes and standards. The elevator hoistway environment can be dusty and dirty. Use dust-tight and waterproof enclosures for all electrical equipment to protect it from the elements. Proper enclosures help prevent corrosion, insulation breakdown, and other problems that could affect the system's reliability. Clearly label all fire alarm wiring and equipment to facilitate identification and maintenance. Labeling should comply with NEC Article 110.21, which covers identification of disconnecting means and other electrical equipment. Clear labeling helps prevent accidental disconnection or damage to the fire alarm system. Ensure that all personnel working on the fire alarm system are properly trained and qualified. Fire alarm systems are complex and require specialized knowledge and skills. Only qualified electricians and fire alarm technicians should install, inspect, test, and maintain these systems. Document the entire fire alarm system installation, including wiring diagrams, equipment specifications, and test results. Documentation can be invaluable for troubleshooting, maintenance, and future modifications. Keep the documentation in a safe and accessible location. Consider the use of surge protection devices, or SPDs, to protect the fire alarm system from voltage surges caused by lightning or other electrical disturbances. SPD can help prevent damage to sensitive electronic equipment and ensure the system's continued operation. The NEC provides guidance on the selection and installation of SPD. If the elevator hoistway is subject to vibration, use vibration-resistant wiring and equipment. Vibration can loosen connections, damage insulation, and cause other problems that can affect the system's reliability. Vibration-resistant materials help ensure that the system can withstand the rigors of the environment. When installing wiring in a vertical run, such as in an elevator hoistway, provide adequate support to prevent strain on the conductors and terminations. The NEC specifies maximum support intervals for different types of wiring. Proper support helps ensure the long-term reliability of the wiring system. Before beginning any work on the fire alarm system, de-energize the circuits and verify that they are de-energized using a voltmeter. Lockout and tagout procedures should be followed to prevent accidental re-energization. Safety is paramount when working with electrical systems. Consider the impact of any modifications to the elevator system on the fire alarm system. Changes to the elevator's operation or control system may affect the fire alarm system's performance. Coordinate any modifications with a qualified fire alarm technician to ensure that the system continues to function properly. If the fire alarm system is connected to a central monitoring station, ensure that the connection is reliable and that the monitoring station is properly notified of any alarms or troubles. The connection should be tested regularly to verify its integrity. Keep the central monitoring station informed of any changes to the fire alarm system. When selecting wiring and equipment for the fire alarm system, consider its life cycle cost. While cheaper materials may save money upfront, they may not last as long or perform as well as high-quality materials. Factor in the cost of maintenance, repairs, and replacements over the system's lifetime to make an informed decision. Stay up to date on the latest codes, standards, and technologies related to fire alarm systems. The electrical industry is constantly evolving, and it's important to stay abreast of the latest developments to ensure that your fire alarm system is safe, reliable, and compliant. Attend training courses, read industry publications, and participate in professional organizations to stay informed. If the fire alarm system is part of a larger integrated building management system, ensure that it is properly integrated and that all systems are compatible. Integration can improve the overall efficiency and effectiveness of the building safety and security systems. Coordinate the integration with qualified technicians from all relevant trades. When installing wiring in a hazardous location within the elevator hoistway, such as an area where flammable materials are stored, follow the requirements of NEC Article 500 through 516. These articles provide specific guidelines for wiring and equipment in hazardous locations. Use only equipment that is listed and approved for use in the specific hazardous location. Ensure that the fire alarm system is designed to operate reliably even during a power outage. Fire alarm systems typically include a backup power supply, such as a battery, to ensure continued operation in the event of a power failure. The backup power supply should be tested regularly to verify its capacity. If the fire alarm system includes notification appliances, such as horns and strobes, ensure that they are properly located and installed to provide adequate coverage throughout the elevator hoistway and adjacent areas. The location and spacing of notification appliances should comply with NFPA 72. Consider the aesthetics of the fire alarm system installation. While safety is the primary concern, it's also important to minimize the visual impact of the system on the building's appearance. Use neat and professional wiring techniques and conceal wiring where possible. Coordinate the installation with the building's architect or designer to ensure that it is aesthetically pleasing. When performing maintenance or repairs on the fire alarm system, use only original equipment manufacturer or OEM parts or approved equivalents. Using non-OEM parts can compromise the system's performance and void the warranty. Follow the manufacturer's instructions for all maintenance and repairs. Before making any changes to the fire alarm system, obtain approval from the authority having jurisdiction. Unauthorized modifications can void the system's certification and create safety hazards. The AHA may require a permit for certain types of changes. Ensure that the fire alarm system is adequately protected from vandalism. Vandalism can damage the system and render it ineffective. Use tamper-resistant enclosures and consider installing security cameras to deter vandalism. If the elevator hoistway is located in an area prone to flooding, take measures to protect the fire alarm system from water damage. Use waterproof enclosures and locate equipment above the expected flood level. Consider installing a sump pump to remove any water that enters the hoistway. Ensure that the fire alarm system is accessible for maintenance and repairs. Provide adequate access to all equipment and wiring. Avoid installing equipment in hard-to-reach locations. Keep access panels clear of obstructions. When selecting a fire alarm system, choose one that is compatible with the building's existing fire protection systems, such as sprinklers and smoke detectors. Compatibility can improve the overall effectiveness of the building's fire protection strategy. Coordinate the selection with a qualified fire protection engineer. If the elevator hoistway is used for storage, ensure that the storage does not obstruct access to the fire alarm system or create a fire hazard. Keep storage areas clear of wiring and equipment. Follow all applicable fire safety regulations regarding storage in elevator hoistways. When disposing of old fire alarm equipment, follow all applicable environmental regulations. Some fire alarm equipment contains hazardous materials that must be disposed of properly. Contact a qualified waste disposal company for assistance. Document any deviations from the NEC or other applicable codes and standards. Obtain approval from the authority having jurisdiction for any deviations. Maintain a record of all approvals. If the elevator hoistway is part of a historic building, take care to preserve the building's historic character when installing the fire alarm system. Coordinate the installation with a qualified preservation consultant. Use materials and techniques that are compatible with the building's historic fabric. Ensure that the fire alarm system is properly tested and certified before it is put into service. Certification verifies that the system meets all applicable codes and standards. Obtain a certificate of compliance from the authority having jurisdiction. Train building occupants on how to use the fire alarm system and what to do in the event of a fire. Conduct regular fire drills to familiarize occupants with the system and evacuation procedures. Post emergency contact information in a prominent location. Regularly review the fire alarm system's performance and make any necessary adjustments to improve its effectiveness. Monitor alarm and trouble signals and analyze any trends. Consult with a qualified fire alarm technician to identify and address any potential problems.